overruns in transportation megaprojects. You don't get cost overruns in transport megaprojects, do you? What a thought. So, over to you guys.
Thanks very much, Peter. Hello, everyone. So I'm just going to share my screen with you. I'm just going to keep my camera turned off, if you don't mind. Oops, it's taking time.
That's okay. As long as you're getting there, we can't see it yet.
Okay.
Is there a problem, Gimhan, or
I'm just trying to find how to upload the presentation slides. I don't see the share screen in my.
Right, share content in MS Teams is top right.
Yeah.
Up arrow, and it then produces. Actually, I think it's just changed recently.
Okay.
It opens up a box where you can share either a screen.
Right. Okay. Right. Just hold on for a second. I got it now.
Yeah. Okay.
Sorry about that.
Excellent. We're there. Thank you very much.
Right. So, right. So I'm Gimhan Godawata. I'm also a member of the Policy Council, System Dynamics Society, and I'm also an assistant professor in quantity surveying at Rework University. So my specialization is actually not system dynamics, but it's more towards construction cost management and project management. But I've used a systems thinking approach for understanding the complexity of cost overruns in transportation mega projects. So just going to give you some background on the transportation mega projects and cost overruns. So usually mega projects, they're defined by their cost threshold. They are large-scale, complex infrastructure projects, and usually the cost threshold for them is over $1 billion US. So you can see how large these projects are. And for example, projects like the Channel Tunnel, the Denver International Airport, and Boston's Big Dig, and Berlin Brandenburg Airport. So those are typical transportation mega projects that have had cost overruns. So the definition for cost overrun is it's rather simple. So it's if the estimated cost or the cost at completion exceeds the estimated cost, we would consider that as a cost overrun. But there are certain debates and there are some gray areas that definition, because some people argue that okay, if it is estimated cost, at which point you decide the estimated cost. So whether it's when you sign the contract between the contractor and the project promoters or the client, or whether it's at the approval stage, because usually these large infrastructure projects, you have to go through the legislature and you need to get approved the budget and everything. So so there's a debate going on that, but for our research we just used the estimated cost and the cost at completion. So moving on to the next slide. So there are some theoretical explanations for cost overruns. We have two schools of thought, call them the psychostrategists and the evolution theorists. So, so according to psychostrategists, their explanation for cost overruns is the cost overruns, they happen due to psychological or cognitive biases of decision makers and political influence to initiate wrong projects. And because you initiate a wrong project, you have problems in the middle when you actually start construction, and then you end up having cost overruns. So that's their definition for that. Evolution theorists, on the other hand, they rather disagree with that definition. So although they agree with the presence of cognitive biases and political influence, what their argument is, so cost overruns, they are a result of accumulated costs caused by changes to the project due to errors made by key decision makers throughout the process, because these large projects, large transportation projects, they take many years to build. So a lot of changes could happen during that period. So so the evolution theorists, what their argument is, they argue that the costs actually evolve or they grow. So, and as a result of the accumulated cost, you have cost overruns. So I'm not taking anyone's side, but we just went ahead with the identifying the gaps in research, for example. So research on cost overruns in construction projects, and they date back to 1960s actually. So there's been a lot of research done on this area. So when I did this research, I actually didn't know whether I had anything new to contribute to this area. But one thing they both agree, the two schools of thought. So they agree that cost overruns is a complex problem. So they have multiple phases. You can look into that problem through different lenses. But the current research available, right, the previous studies done on this area, they predominantly rely on reductionist approaches. So for example, just ranking the factors causing cost overruns, but nothing after that. So if you see the number of publications on cost overruns, all what you see is identifying factors and ranking them using a ranking index. For example, it could be relative importance index or mean scores, whatever it is, but that's the way that's been happening, the research. But what we identify is there's a lack of holistic approaches, for example, systems thinking. So because one thing for sure is you can't actually blame one factor to take the responsibility of cost overruns. It's a multifactorial problem. So you need to approach that problem. You need to analyze that problem using a holistic approach, such as systems thinking or system dynamics even further. So that was our approach. So we used systems thinking to analyze this complex problem of cost overruns in transportation mega projects. So our research approach, actually, it's predominantly a qualitative approach, I would say. So we built a qualitative model based on grounded theory. So the analysis method that we used was something very common in qualitative research, the grounded theory, and the systems thinking approach. So we converted the findings of grounded theory into a systems map or causal loop diagram, you call it, and we selected a case study. That's the California high-speed rail project. That's actually the first high-speed rail project in the US. It's still going on, and they've had massive cost overruns, a lot of delays, and a lot of problems. So just to give you an insight to the case study that we've selected. So they've had plans since 1980s, I would say, to initiate high-speed rail projects in the US, but only in 1996 they actually decided to conduct a feasibility study and to decide whether they're going to actually have high-speed rail projects in the US, and particularly in California. So in California, so they established a project organization called a California High-Speed Rail Authority. So and then they approved the project in 2008. It was actually in the election in 2008. So the voters had to approve the project. So the initial length of the rail network was 800 miles. And they had to connect main cities of Sacramento, San Francisco, Los Angeles, and San Diego. And they actually wanted to complete it by 2020, which was last year. And so due to the delays they had, so they, according to current forecasts, I think they are going to complete the project in 2030, and that's, we're not sure. And the estimated cost that was promised to the voters was 45 billion US dollars in 2008 dollars, and the current estimate is that's going to be 80 billion US dollars just for the first phase of the project. So what happened was when they found out that it's going to cost a lot and they had a lot of problems. So they just used a segmental approach. So they just changed the scope of the project. So the initial segment is going to be about 109 miles. So that's going to cost around 80 billion US dollars as opposed to the 800 mile long project. So the major issues they had were they had a lot of lawsuits and construction delays as well due to lawsuits, and also they didn't have a direct funding stream. So, and that was also subject to political negotiation as well. And they actually didn't have any expertise to plan mega projects, the California High-Speed Rail Authority, because the decision makers, the project managers who were employed in the California High-Speed Rail Authority were people who were coming from California Transportation Authority, I would say. So they just created this project organization, but they were used to building highways and small rail projects, but they have never had the experience of building high-speed rail projects. So they lacked the expertise. So they went ahead with unrealistic cost estimates, and also they had problems with polarized politics as well, because being a liberal state, I would say, led by the Democratic Party, after President Donald Trump came to power, they had a lot of issues, not directly related to the project, but these issues between the governor of California and President Donald Trump actually resulted in the federal withdrawal of the federal funds for this project. So now they're facing a serious funding risk as well to continue the project. So what we did was we actually collected data through 23 interviews, and we also went through newspaper articles written on the project. We got in touch with first we got in touch with key decision makers in California High-Speed Rail Authority, and also we interviewed contractors representatives as well, and we've got some outside consultants as well, and also some stakeholders from the community. So we had 23 interviews and newspaper articles. In addition to that, we also went through board meeting transcripts. So they are all available on their website, the California High-Speed Rail Authority website. And we also went through the audit reports of the California auditor and the US Auditor General. In addition to that, we also went through 4 contract documents because of the segmental approach they used. They divided the project into 4 major contracts, and then we went through the contract documents as well in order to collect data and analyze the data. So for the analysis part, we use grounded theory. I think this is a well-known method for qualitative researchers. So you use grounded theory, and it's a systematic qualitative data collection and analysis approach. So you create or you construct a substantive theory that is grounded in actual data. So this is ideal for researchers who look for establish cause and effect relationships, causality. So I would say systems thinking is also an approach where you look for cause and effect relationships, and you try to match causality and see how the causes effect and the underlying causal mechanisms. So we use grounded theory for systems thinking as a theory building approach predominantly because this was more qualitative, I would say. So we started with open coding. So we had to transcribe the interviews. We already had the newspaper articles and board meetings transcripts and everything. So we first went through coding using raw data and identify key variables, and then we had to list out the key concepts and themes. So we used in vivo software to do the coding. So we generated a hierarchical coding structure, and when it comes to axial coding, you identify causal relationships between the concepts, and then you have the main coding chart. And then for selective coding, you do an abstraction of the identified causal relationships. You try to merge data patterns, and then you generate causal maps for each core theme. So we identified 4 core themes. And then the final part is the substantive theory, the formation of the theory that explains the identified causal relationships. So that's the final causal map, or the systems map that we generated. So giving an example of the data analysis, this is an example of open coding. So if you see here, so interview participant number 22, it says part of the issue is the controversy and the political polarization of a high-speed rail project in the United States. So we coded that as political polarization with a question mark whether they are going to use it or not, because it's still undecided at this stage. Again, we have funding availability and also support from the legislature. So these were some of the codes that we used. And in the next stage, when you use axial and selective coding. Here you see an example of the themes and also axial codes, the hierarchical coding structure. So the 4 themes that we got were external actor relations, or we actually named it as external actor resistance in the causal loop diagram. And under that we had authority, community opposition, laws and regulations. And then we had ignorant strategic leadership. And also we had immature project organization and political power relations. So this here is an example of the axial codes that you have under commitment. So the politicians were kind of committed to initiate this project. So they had the full support from the legislature. So what happened was they actually misrepresented the real cost of the project just to get the project approved from the voters, and then they had to promote the project to obtain the consent for the project. In addition to that, they also had pressure from labor unions because they wanted jobs, they wanted more jobs. So a project at this scale would actually generate a lot of jobs. So so these are 2 examples of the coding structure. And this is the final output, the causal map. One thing I forgot to mention was we actually used a separate color code for each theme. So for external actor resistance, we used pink, and we used blue for ignorant strategic leadership. And for immature project organization, we use green. Political power relations, we use orange. So using the same colors, we construct the causal map, or the substantive theory we call it. So here you see some feedback loops. So this is the ignorant strategic leadership causal loop diagram. I'm not sure whether it's very clear. So what happens here is you see the strategic leaders, or the decision makers, they were very ignorant. They actually didn't have any experience of planning and delivering a mega project at this scale. But they were also had the false hope of everything's going to be all right. So a sense, and then they were also, they had this optimism bias as well. So with that, they neglected the project risks, and they also underestimated the project costs as well. But when the actual problems started happening, they were also in the illusion of control. They thought they had the full control of the project, and they kept on trying to solve the problems without even knowing that they didn't have the capability of solving those problems. And then here in the green color, you see immature project organization. Under that you have, I'm sorry, it's very small. I don't think you can actually see the letters. But the project was initiated with undefined strategic business objectives. So they didn't have any plans for how to negotiate with the stakeholders. Especially they had a lot of problems from the farmland owners and also environmentalists. So, and they sued the California High-Speed Rail Authority, and they had multiple lawsuits, and so billions of dollars had to be paid as compensation. So that actually was the additional cost, which increased the cost, the estimated cost. And also here you have the political power relations model. So in this one you see a lot of loops. So you initiate the project with unrealistic promises to the voters, and you get the approval. you are committed, but then you also initiate the project with pressure on the decision makers, because the project initially they had funding from the federal government, but they had a deadline, so they had to use the funds before the deadline. So what the decision makers did was they only had planned the project for, like, let's say between 15 to 30% the critical planning tasks, but they just initiated the construction contracts without even completing the critical plans. So that actually resulted in a lot of problems, right-of-way acquisition problems, utility relocation, multiple lawsuits. And then President Trump came to power, and then he started creating more problems for the project, and also the California government as well. So as a result of scope changes, multiple lawsuits, you had to pay compensation for the stakeholders, and also you had to pay compensation for the contractors because their work was getting delayed. So as a result of multiple factors, the costs in this book, I've shown the cost overrun variable here. So the costs actually escalated drastically, and the current estimate, the project is still going on, but the current estimate would be at least 80 billion US dollars. And one thing you can see here for sure is the presence of arguments of both schools of thought here. So you see something from the psychostrategist. So they say the decision makers have cognitive biases, which in our research was quite evident. And also they had scope changes as well. So I would say both cases were present in this project, but we need to do more. We need to find more cases, and we need to see whether this model can be applied to any context, at least for construction, transportation mega projects. And I would say the major limitation of the work was the model based on data from one case study. So if we are to generalize the results of findings and that model, we will need to find more case studies and see whether the model can be replicated in those scenarios as well. And also something important, complete the stock and flow diagrams and do the system dynamic simulation, because all what you see here is the substantive theory or the causal map. It's a static theory, I would say, but the project is not a static theory, so it should be a dynamic theory. So for that you need to do a simulation and see how the cost overruns emerged as a result of the interactions between these causes and effects. Yeah, and so that's everything that I have to share. I think I'm on time. So yeah, thanks very much, guys. Thank you.
Okay, Gimhan, we've got a couple of questions for you in the chat. First one from John. Useful to hear of two schools of thought about cost overruns. There's also the SD-based theory of undiscovered rework. How does this view fit?
So in this case, yeah, we actually asked about rework from the interview participants. So the model that they had, the procurement model they had, was the design and build model. So it was actually, if there's going to be any rework, so that's going to be the contractor's responsibility in this case. But it all depends on, I think it depends on the procurement route that you're using. So if the client is going to bear the risks of the design, so I would say Yeah, in that case, you will have more cost overruns on the client side, but because this was a design and build project, the participants, they noted that it actually was contractors' responsibility. So yeah, I would say a lot of rework, yeah, because there's a lot of research done on rework as well, and how cost overruns emerge from rework as well, especially there's a professor in Australia, Peter Love. So he has used system dynamics models to evaluate the rework causation and how they contribute to cost overruns as well. Yeah, okay, I would say it's common. Yeah.
Can I ask a supplementary there before the second question is, which is just a piece of information in terms of progress. You introduced it in terms of a project that was supposed to be delivered by 2020, now 2030.
That's right, yeah.
Clearly there's an awful lot of planning and pre-work that goes in. So in the context of rework, is it actually on the ground at all? I mean, are they building things? No.
They are still building the key infrastructure. So still they haven't even gone to the next stage, like the track installation or anything like that. They're still doing the bridges and you know, those things. Yeah.
And so, and of course, rework can refer just as effectively to getting to the shovel moment.
Yeah.
Because you have to go through all those processes. Fascinating.
That's right.
Sorry, James, I'm taking your job here, but as I interjected, the second question was from Philip Dixon. Are there common factors in mega projects which could allow the prediction of the magnitude of likely cost overrun?
Well, I would say yes. I mean, from the results that we see, so yes, decision makers, I mean, they are kind of optimistic, I would say. When it comes to cost estimates, so they initiate projects with unrealistic cost estimates, and sometimes you also don't have a budget to support. So one of the things that was mentioned by the interview participants was, okay, this was a good vision, the high-speed rail project, but they didn't have a budget to support it, and they seriously underestimated the costs. So so cost underestimation is one factor, and the underlying causes for that could be cognitive biases or ignorance. I mean, in our case, we actually had both ignorance and also cognitive biases as well. So ignorance, in the sense, we consider that as the lack of information or lack of knowledge. Plus, we also noted that the decision makers didn't actually realize that they are ignorant. So and that was something important as well. So not realizing your own ignorance could be a vital factor as well. And yeah, when it comes to mega projects, you would always have people supporting the project, and also you will have people opposing the project. In this case, yes, it was a lot of lawsuits from farmland owners and town councils and also environmentalists. But the problem was the lack of stakeholder engagement. So they actually didn't have any plans whatsoever to negotiate the project outcomes or anything like that, and reach the communities. So they just went ahead with construction without even placing the third-party agreements. So that was also a problem. Yeah.
Okay, we've got a question from Hugh Rees for you. How much did you encounter / reveal on the strategic procurement structure? You mentioned design and build. Was there evaluation of strategic procurement options?
The 4 construction packages right now, they're using design and build procurement option for that. But then also they have other procurement options for the service providers, but we haven't been into that stage yet. So I think when they actually initiated the project, they had the idea of finding possible private financiers to finance finance the project, and then move to a public-private partnership model. But now with cost overruns and all these issues, the private financiers, they are actually stepping down, so they are not going to invest money on a project that's not going to look very good on them. So that's also been a problem that also contributes to the funding risk they have right now. So these ones, the current projects in progress, so they have 4 construction packages, and they only do the civil engineering infrastructure works for the project. So those projects, I think the total value of those projects was something close to $4 billion. But then with the current estimate, I think they had to spend around or more than $6 billion only for those packages. Yeah, so you had design and build option for those engineering or infrastructure part, but then you also have a service provider contract separate from that, and then they were trying to move to a PPP model after that. Yeah.
Right. Okay.
Thank you.
We're spot on time for a short break. Thank you very much, Gimhan. And I think there is certainly a generic sort of theory there in terms of because we do see cost overruns in mega projects, and I was struck by the possibly even emotive language. The ignorant, the immature, and the resistors are all sort of the things of a disaster doom, and I'm surprised that they're you know, I suppose it could implode, but something is keeping it going. A good generic framework there, and we could talk for a long time about it. But thank you for that.
Thanks very much.
We're 10:46. We will restart promptly at 11. This is your comfort break and coffee moment.